Welcome. We will be looking at how to find the derivative of a function that is the product of two other functions. Um, the derivative of a product is not the product of the derivatives. That is, if I have two functions f and s, and I am taking the derivative of f times s, that's not the same as the product of the derivative of f and the derivative of s. So the derivative of a product is not the same as the product of the derivatives. So here's an example. Let's say I have f of x is equal to x to the 4. S of x is x to the 5. So then if I denote the product of capital F and S by lowercase f, then lowercase f of x would be x to the 4 times x to the 5, which would be x to the 4 plus 5, or x to the 9. So then clearly the derivative of this product is 9 times x to the 8 by the power rule. Now, if you look at the derivative of capital F times the derivative of capital S, what we get is derivative of capital F would be 4x cubed, derivative of capital S would be 5x to the 4, and then clearly this quantity would be 20x to the 7, and that's not the same as the derivative of this product, which is 9x to the 8. So we see that the derivative of this product is not the same as the product of the derivatives of the two vectors. Now I'm going to calculate this this quantity right here, where we take the derivative of, so we're looking at this product f of x times s of x. So think of f of x as the first factor and s of x is the second factor. So when you take the derivative of this product, you take the derivative of the first factor multiplied by the second factor as it is, plus the first factor multiplied by the derivative of the second factor. And so if we calculate this quantity, what do we get? Well, f prime of x would be 4x cubed, s of x is x to the 5, capital F of x is x to the 4, s prime of x is 5x to the 4. So if we do the algebra, we get 9x to the 8. So now notice that the derivative that we calculated at the beginning for the product here matches the quantity that we just calculated here. So that tells you that the derivative of this product it may be equal to this quantity right here, which is indeed the case. So here's the product rule. Suppose that capital F and capital S are differentiable functions, and lowercase f of x is the product of f and s, product of capital F and capital S. Then what's the derivative of this product? Well, the derivative of this product function is equal to f prime of x times s of x plus f of x times s prime of x. So the way I read this is that your function lowercase f has two factors in it. So the derivative would be the derivative of the first factor multiplied by the second factor as it is, plus the first factor as it is multiplied by the derivative of the second factor. This in short can be written as f dot s prime is equal to f prime s plus fs prime. Let's say I want to use the product rule to find the derivative of x plus 3 times 2 minus x. So here I'm going to think of this as the first factor and this is the second factor. So by the product rule, we take the derivative of the first factor. So by putting a prime, I'm denoting the derivative of the first factor, multiplied by the second factor as it is, plus the first factor as it is, multiplied by the derivative of the second factor. Now let's plug in the derivative of the first factor. So we know that the derivative would be the derivative here would be the derivative of x plus the derivative of 3. The derivative of x is 1 and the derivative of 3 is 0. So here I get 1. So I get 1 times 2 minus x. Similarly, here I get x plus 3, and then here the derivative would be derivative of 2, which is 0, minus the derivative of x, which is negative 1 then. So then we get this, and then we just simplify that, and we get negative 2x minus 1. Now instead of using the product rule, we could have found the derivative another way, which is we could have multiplied the two factors here first and then apply the power rule. So let's do that. So if I multiply x plus 3 and 2 minus x, I'm going to get negative x squared and 2x and negative 3x and 6, and simplify that. What we get is okay, I should have simplified 2x and negative 3x, but that's fine. I'm taking the derivative here, so I get derivative of 2x is 2, derivative of x squared here would be 2x, derivative of 6 would be 0, derivative of negative 3x would be negative 3. So we see that we get negative 2x minus 1. So in both ways we get the same answer. So we can see that the product rule actually works. That it can be used to find the derivative of a product of two functions. So let's say I have the function f of x, which is equal to 2x plus 3 times x squared minus 18. So what I want to do is we want to find the slope of the tangent line to the graph of f at the point where x is 3, and we will show that slope is 36. So to do that, we need to find the derivative, and to find the derivative here, I'm going to apply the product rule. So if we apply the product rule, what do we get? The derivative would be the derivative of the first factor multiplied by the second factor plus the first factor multiplied by the derivative of the second factor. So now, what's the derivative of the first factor? Well, that's going to be 2. Derivative of the second factor here would be 2x. So we get 2 times x squared minus 18 plus 2x plus 3 times 2x. Multiply out everything. I guess I didn't simplify this. So what's the derivative at 3? Well, we just plug in 3 in place of x. So if we do that, we get 9 here, we get 6 here, and we get 6 here, and then this quantity can be simplified to 36. So we see that the derivative of f at 3 is 36. So that's the slope of the tangent line to the graph of f at the point 3 comma f of 3. So now let's say I want to find the equation of the tangent line to the graph of f at x equals to 3. This is the same f here. So we already know the slope of the tangent line at x equals to 3, and we just have to calculate f of 3 because we want to find the equation of the tangent line at the point 3 comma f of 3. So the point corresponding to this x value is what? Well, this is f of x, so f of 3 is f of 3 would be 6 plus 3 and 9 minus 18, and that is equal to negative 81. So then we want to find the equation of the line through the point 3 comma negative 81 with slope 36, and by using the point slope formula, it is y minus 81 is equal to the slope 36 times x minus 3, and we can simplify that to the equation y is equal to 36x minus 189. So that's the equation of the tangent line to the graph of this function at the point 3 comma f of 3. Now I want to find the values of x for which the tangent line to the graph of f is horizontal. So we want to find all the points on the graph of f where the tangent line is horizontal. So how do I do it? Well, basically we want to find the points where the slopes will be 0, right? So we already know the derivative. So recall that we calculated the derivative right here. So this is the derivative, and then we want to figure out where the values of x for which the derivative is 0. So to answer this question, we start with the derivative and set it to 0. Since the horizontal lines have 0 slope. So set f prime to 0, so we get this. Simplify the derivative here. We're going to get a quadratic. So you get 2x squared here and then 4x squared here. So that's 6x squared. We get 6x out of here, and then we get negative 36 from here. So this is the quadratic that we get. And then we can divide both sides by 6, and the equation simplifies to x squared plus x minus 6, which we can factor out now as x plus 3 times x minus 2. And as a result, we see that either x is negative 3 or x is 2. So these are the values of x where the tangent lines are horizontal. So to find the points where the tangent lines are horizontal, we simply find values of x for which the derivative vanishes or the derivative is equal to 0. Okay, so let's say I have this function f of x is equal to 5x to the 8 times e to the x. I simply want to find the derivative by using the product rule, and then I want to simplify that. Okay, so when we are applying the product rule here, I'm going to think of this function as the product of two functions. So I'm going to think of 5x to the 8 as the first factor and e to the x as the second factor here. So the derivative by the product rule would be the derivative of the first factor multiplied by the second factor plus the first factor multiplied by the derivative of the second factor. Now we know here 5 is a constant, so this derivative here would be 5 times the derivative of x to the 8, which is 8x to the 7. And so you get 8x to the 7, which would be 40x to the 7. And then the derivative of e to the x is e to the x, so we get this. And so what we're going to do here is that we will factor out e to the x, and if we do that, we get 40x to the 7 plus 5x to the 8. And notice that right here I can still factor out a 5 and x to the 7. So if I factor out a 5, then I get 8 here. 5 times 8 is 40. I'm factoring out x to the 7, so I only get 8. I'm factoring out 5 and x to the 7, so I get x left here. So then we get e to the x, so 5x to the 7 times 8 plus x. So I am going to rewrite this as 5x to the 7 e to the x times x plus 8. Okay, so we want to find the derivative of the given function here, and then we want to simplify that. And the function is the following. It is 5 plus 4x minus x cubed times e to the x. Well, it's a product of two functions, so this would be my first factor, and this would be my second factor. Product rule tells me that I take the derivative of the first factor multiplied by the second factor plus the first factor multiplied by the derivative of the second factor. And the derivative here, that's a polynomial, so we know what to do. Derivative of 5 is 0. Derivative of 4x is 4. Minus the derivative of x cubed would be 3x squared, so I get 4 minus 3x squared here. And the derivative of e to the x is just itself. So what do we get? So right here we can factor out e to the x. So if we factor out e to the x, we get 4 minus 3x squared plus this quantity here. It's 5 plus 4x minus x cubed. And then let's simplify this expression. So we get e to the x times negative x cubed, negative 3x squared, plus 4x, plus 5 plus 4 is 9. So that's that is the derivative of this given function, where we simplified the answer as well. Okay, so I'm going to stop the video here. In the next video, we will be looking at derivatives of quotients of functions. See you soon.